I'm just going to make a quick video right now to give anybody who is subscribed a heads up that in the next couple of weeks I'm going to do a teardown of my copter and a minor rebuild with a couple of new parts. And I thought I would talk to you for a second about the parts I'm going to be putting in and why I think they're good parts. Um, the first thing I'm doing is I'm changing out my ESCs. I currently have F12A ESCs from Ready to Fly Quads running BL Heli 13, and they're fine ESCs. They're not terrible. Probably not the worst out there, but for example, they can't run BL Heli 14 satisfactory to me. When I upgraded them to BL Heli 14, the more aggressive braking that BL Heli 14 implements caused me to have, well, I don't know for a fact that that's what it was, but I do know that when I went to BL Heli 14, I had these weird sort of shakes that I could not tune out no matter what I did, and I tried a lot of things. And when I went back to BL Heli 13, it was gone. So, so what I've learned from that is that if you're going to fly a mini quad and you're going to fly aggressive acro flight like I'm trying to do, then you need some quality ESCs. And there's two major microprocessors that are used on most all ESCs out there, and they are Atmel and Scilabs. Those are the two manufacturers. And Atmel are found in a lot of the cheaper ESCs. They have the advantage, well, number one, they're cheap, and number two, they're really easy to work with as a developer and as a user. The development tools for Atmel ESCs are basically free, um, and as a user, you can just download Arduino IDE and you can flash an Atmel chip really easily. Whereas Scilabs, I've never personally worked with Scilabs, but I believe the development environment is a commercial product and so on. But the Scilabs ESCs, and I don't know the details on this, but they tend to have much better performance. They run at a faster speed, is one thing, and I believe they also have integrated hardware that helps them operate the FETs better. So an ESC basically all it's doing is it's switching on and off the uh, the phases of the motor to make the brushless motor spin, and it does that with a chip called a FET, field effect transistor, I think is what it is. And you can think of a transistor as just a digital switch. Basically, it just turns on and off to let current flow or stop flowing. And with the ESCs, basically, the faster you can turn the FETs on and off, the better the performance you can get. And a lot of ESCs will have a driver, a FET driver made up of discrete components like resistors and capacitors and whatever. And there's another thing called a discrete gate driver, which is a dedicated chip whose only job is to turn the FETs on and off as fast as possible. And that's a thing that these ESCs that I've got on screen right now have. And I believe, and if I've sort of uh, inferred all the information correctly, that's one of the things that makes the KISS ESC such high performance as a dedicated gate driver. And it's something that very few ESCs have. Even very, very good ESCs like the RG20s apparently don't have a dedicated gate driver. So I hope I've gotten all the technical details right here. If I haven't, I hope someone in the comments corrects me. But that's my understanding. So I'm going to put these Multi-Rotor Mania Zeus. They're the same as the Little Bees. If you've heard of the Little Bees, they're going to run BL Heli 14, which I really like that they run BL Heli. The KISS ESCs are good, but they run their own proprietary firmware, and I kind of like being able to tweak with BL Heli Suite and the development pace of BL Heli. Also, the KISS ESCs have a tendency to go up in flames when things go wrong, and hopefully that will not be the case on these, although they're still so new that it's hard to judge. So I'm going to try that. I'm going to these ESCs because when I went to BL Heli 14, the performance the flight performance was way better. Even on nothing else changed. I tweaked my PIDs a little bit, and I was just able to do more aggressive yaw moves, more aggressive turns without the motors sort of flipping out and losing orientation. It really just breathed new life into the copter, but I had to go back because I couldn't tolerate the vibrations and jitters that it was causing. So it really hit home to me the difference that a good ESC can make on your flight performance. And frankly, I mean, these are 16 bucks, okay, so they're not the cheapest in the world, but it's a difference of, 4 times 6, it's just a difference of 25 bucks over 4 ESCs compared to something like cheap, like a $10 ESC. For 16 bucks, I think I can afford these. If these are in fact like the best or up there with the best, then I think I can handle it. Given the difference in flight performance that just going from BL Heli 13 to 14 made, I really hope that this really improves my flight performance. Another thing I'm going to be doing is I'm going to be going from my current receiver, which is the FreeSky D4R. Is that right? Is that what it is? Yeah, the D4R2, which is a PPM receiver, to the X4R SB, which is an S-Bus, a serial S-Bus receiver. I've learned that whenever you're doing PWM or PPM, there is a 4 sample averaging that happens on the input. And the reason for that is that any analog signal, you can get some corruption on the signal, and you don't want one little corrupted part of your PPM or PWM signal to cause like the flight controller to think an aux switch has flipped. Like what if you arm or disarm with aux and one bit comes in bad and it makes it think you've disarmed in the middle of your flight, right? You don't want that. Or it makes it think that the stick position has changed and so the copter twitches. So it does this 4 sample averaging. Well, what that means is that you got with the standard firmware, you've got 18 millisecond ppm frame spacing. So 18 milliseconds times 4 samples is 72 milliseconds of delay just for that averaging. That's 72 milliseconds of delay between the time that you move the stick and the time that the copter starts moving. And if, like me, you flash the 27 millisecond firmware on there so you can get all 8 channels without any sort of problems, then that's 108 milliseconds of delay. And that is just in the averaging. That's not any other part of your video link, any other part of the whole sort of link between you seeing a tree branch coming at you and you moving the stick and the copter responding. It's just that 4 sample averaging that comes in with the PPM or PWM input. So I've noticed lately that when I'm doing proximity flight, like if I'm going to do a turn around a tree or something, I have to turn into it. I have to push the stick into it before the copter appears to have cleared the tree. And I've been thinking, well, what's that all about? Well, probably a big part of that is this delay. That if I wait until the moment that I actually want to start turning and push the stick, the copter swings wide. And I've started compensating for that by turning into the turn before I actually have a clear sight line of where I'm going. And that works okay while I'm, at my house where I know all the ins and outs and turns and flight lines. But it would be a real killer if I was flying in an unfamiliar environment. It just would be, it would be a killer. So I'm going to go to serial. That's going to involve some shuffling since I'm doing FreeSky telemetry, which I kind of don't want to give up, even though I also have an OSD. I kind of like the telemetry as a backup to the OSD just to give me RSSI and battery warning. I'm doing black box logging and black box telemetry. Oh, and S-Bus. Okay, so the problem will be that S-Bus has to be on a hardware UART and black box has to be on a hardware UART, and I'm running a Naze board, which I only have 2 hardware UARTs. So I'm going to have to probably put black box on UART 1 uh, and only have it work when I'm armed, and then S-Bus on UART 2, I think is what I'm going to do. So I'll have to shuffle that around. I'm also going to be going from my current PDB, which is the Strider OSD, to the Strider Flex. The main advantage of this is that I can use MinimOSD with the Strider Flex. I'm very excited about this. When I first ordered the Strider OSD, I didn't realize that you could use MinimOSD to adjust your PIDs and other settings via your transmitter sticks. And if I had known that, I would have gotten the flex from the beginning. I just thought it was, oh, it's, just putting your battery meter and your timer up. I had no idea that there was two-way communication. So now I know. And I have recently slightly damaged my PDB or some part of it, and need to replace it. So I'm going to go ahead and replace it with the flex, which is convenient because I was going to have to desolder all my ESCs and everything anyway to put the new ESCs on. So I may as well move over to this board. So I'm going to try to document all that as I go and maybe post some videos and so forth. And that'll be coming up. I should be getting the ESCs. I should be getting them by the end of next week, which would be the 18th, I hope, maybe early the week after that, the 21st. And I hope I have most of the other parts all. I don't have the receiver, but I have the other parts here, the OSD, and obviously my copter is all still here. So that's coming up, and I hope you'll enjoy it. Bye bye.